one more example of a calculation you can do involving molarity. I like this one because it asks us to explain how to prepare a 0.25 molar solution of copper 2 nitrate. And eventually, this is what we're going to do in the lab. That they'll give us a certain volume. This one does not. So I don't know. Let's just maybe say, let's pretend we want 500 milliliters. Now that would tell us, make 100 milliliters or make a liter or whatever it is. And they'll also give us a concentration. So we want, let's say, 500 milliliters of a 0.25 molar copper 2 nitrate solution. Okay, so in the end, the 500 milliliters is mostly coming from water that I'm adding to some copper nitrate. Copper nitrate is normally a blue kind of crystalline solid. And most solutions that we make in the lab are solids that are now dissolved in water. So if I'm going to measure an amount of copper 2 nitrate starting as a solid, it'll be measured on an electronic balance using grams. So somehow I need to figure out how many grams of copper 2 nitrate do I need to add in enough water to make 500 milliliters of solution. Okay, well, let's see what we got here. We know from the previous video that molarity is a measure of moles of solute per liter of solution. Well, I have the molarity. It's 0.25 molar copper nitrate. Copper 2 nitrate, meaning copper's plus 2. NO3 is the nitrate ion, minus 1. So I'll need 2 of those. All right, molarity equals, I don't know the moles, but I do know the volume. I want 500 milliliters, but that would need to be used then as 0.5 liters. So if I cross multiply, that gives me about a big fat 0.125 moles. Well, if I know moles of this copper nitrate, I can go from moles to grams, right? And by the way, to solve there, in case our algebra skills have left us, remember we're going to cross multiply now. So we're going to take that 0.25 and we're going to multiply by 0.5. And often, again, we just like turn into boneheads. Stoichiometry is a little different. The sign in the middle is a multiplication sign. And then we like multiply across and divide by anything on the bottom. This is an equality. So now I'm going to like cross multiply. And it's as if I'm pretending that this is over 1. So if I cross multiply, I get like 1 times moles equals 0.5 times 0.25. Oh, algebra. It's good stuff. Anyways, yeah, once I've got this 0.125 moles, I can turn that into grams. And again, if I'm measuring a solid solute, I'm going to need to measure it by mass on an electronic balance. So then I can take this 0.125 moles of copper 2 nitrate and just do one more little calculation. Oh, this is so great. Where I'm going to cancel moles and switch it to grams. I want it in grams. 1 mole has the mass on my periodic table. I just need to add. So I need a copper plus, now we have to distribute that 2, so it's going to be 2 times the nitrogen plus 2 times 3, 6 oxygen. And I'm getting about 187.57 grams. Here's kind of what I was referring to, like, when we do these mole calculations and stoichiometry where, we could have like multiple setups in stoichiometry. Do you see how this is different? This is multiplication. And then we can multiply across the top and divide on the bottom. This is an equality. This is different. This time I need to cross multiply in order to solve for that moles. There we go. Okay, so I'm going to multiply 0.125 times 187.57. And I'm looking at about 23.4 grams of copper nitrate. Okay, so here we solved for moles and then converted moles to grams. This is great. Now the question says to explain how are we going to prepare the solution. Fabulous. Step 1. I'm going to measure 23.4 grams of that copper nitrate. I'm going to write in there, it's a solid. Most of these solutes are solids. We're going to add that then to a beaker. Oh, I should put beaker or volumetric flask. Okay, so obviously we are here making 500 milliliters of solution. So I would want to choose an appropriate beaker. I'd want to pick a beaker that has a mark for 500 milliliters. So I probably don't want to use like a little tiny beaker that's just not going to fit. The other option is something called a volumetric flask. And we'll look at these in the lab. Volumetric flasks are a little bit different than the flasks that are in your drawer. They're kind of like a really long, skinny neck. Well, this is going to be a good one. And then here's like the bulb on the bottom. Oh, it's something like that. And so volumetric flasks will have one marking. And so that one marking might be for 500 milliliters. And so you have to use the right volumetric flask. I wouldn't use a 250 milliliter volumetric flask, or I wouldn't use a liter volumetric flask. Volumetric flasks will seriously only have one marking. Now, maybe I could use a liter beaker if it had a marking for 500 milliliters. But these volumetric flasks are great for making solutions. And I'll show you a couple examples of them, and then we'll use them in the laboratory. Okay, so put that solid, measure the solid, put it in a beaker or the appropriate volumetric flask. Now, here's how you have to be a little bit careful on how you word this second part. We're going to add distilled water until 500 milliliters total volume. And then finally, we would just stir to dissolve. Stir to dissolve. Okay, so the wrong way of wording number 2 is to say add 500 milliliters of distilled water. There's a reason why we put the solid in the beaker first, and then we add the water. We want the final volume to be 500 milliliters exactly. So first I put my solid in, and then I add enough water until the total volume is 500 milliliters. I don't measure 500 milliliters of distilled water. Here's why. That 23.4 grams of copper nitrate. I mean, even when it hits the water and it starts to dissociate and dissolve, those copper ions and nitrate ions will take up a little bit of space. And I want the final volume to be 500 milliliters with the solid plus the water. if you were to put 500 milliliters in a beaker or a flask, like you measured exactly 500 milliliters of liquid water, then you add 23.4 grams, your final volume will actually end up being more than 500 milliliters. Because again, that solute, those particles will take up some space. They have volume. So we put the solid in first, and then again, I don't measure the water. I just add water until I hit the desired volume. So technically, it's probably a little bit less than 500 milliliters of water. But again, then that's taking into consideration the volume occupied by the copper ions and the nitrate ions. Ah, that's great. And then finally we would stir, or like these volumetric flasks are kind of cool because you can swirl them around really easily. And that helps to dissolve your solid. Again, a fabulous lab skill, something that we're totally going to do in the lab, and something that you would use quite a bit if you were to ever take any further science, whether it's biology or further chemistry. Being able to make solutions of a certain concentration, super important skill in the laboratory.